Hey, what is up everyone? Tyler Answer here, back with another video. Whether you are joining me right now on the HackSmarter Twitch channel or maybe after the fact on YouTube, as I always say, but I really mean it, it is an honor for you to take the time to hang out with me and to learn together. And for today's stream, I have a really special treat for us. So if you are in the TryHackMe world at all, you'll notice that TryHackMe has been releasing a lot of really cool networks the past few days, specifically networks geared around Active Directory hacking. Many of these networks, well, I think all of them are actually built on top of a base network that was created by a TryHackMe staff member. We'll call it his hacker handle is am03bam4n, spelled with a bunch of leet characters. So when I first saw it, I had no idea how the heck to pronounce it. But am03bam4n has connected with me over Discord, and he's been really helpful joining on streams and helping us troubleshoot and teach things. And he offered to show us how to set up our own Active Directory lab with something called Vagrant. And so I asked him if we could just take a stream and he could guide us through this process, and he graciously agreed to do so. So I'm pumped, I'm excited. I set up an AD lab in the past couple of weeks, but I did it a very old school way, and it took me a long time, and I didn't even get to the point of having users or anything. I just got the domain controller and 2 user computers set up, but didn't do anything else, and ran into a lot of issues in the process. So I'm looking forward to learning it this way. And so here's what we're gonna do. I am gonna try this, and for those of you on Twitch, go ahead and post in the chat if something sounds buggy or seems buggy, because I've never done anything this way. But I'm gonna share my screen, which should then share am03bam4n's screen, and I'm gonna let him drive, and he's gonna guide us through this. So I will be monitoring the Twitch chat, and also if you're part of the WorkSmarter Discord channel, we're also live in there in the box hacking room, so you're welcome to join on Discord as well, and you can ask questions as we go. One final note before we dive into it: you're going to notice there's no background music, and that's because Twitch got angry at me in my last stream and hit me with the copyright. I didn't get any violations, but it muted the first 6 minutes of my video, so it's just me moving my lips and no sound coming out. So now I have to go kind of re-edit things and fix things. I realized it after the fact, after it already premiered on YouTube. So anyways, there's no background music, so if you don't hear music, that's on purpose. Now, I'm gonna go ahead and try to share my screen, which is working, and I don't think you guys need to see my talking head in the top right corner, so I'm gonna take my talking head and just move it off the screen. And I'm gonna pull up Twitch just to verify everything there looks good, and it does. So, am03bam4n, thank you again for joining us. Thank you for hanging out. I will turn it over to you, and I'll let you drive.
Thank you, appreciate that. Hi there, everyone. So, looking forward to showing you all how you can use something like Vagrant to create some networks. So a little bit of background on Vagrant, and then I think we'll jump right in. And yeah, Tyler, you can let me know if there's any questions from anyone, or if anything's unclear, or even from yourself as we move along. So basically, Vagrant is a application or a tool that HashiCorp has released, which essentially allows for what we call infrastructure as code. So when you think about sort of your software development lifecycle or your DevOps practices, in the old days, those were only for the actual applications that you were building and sort of creating. And then when it came to the environments, there weren't necessarily a lot of things out there. It was still quite a bit of a manual process. But with sort of the rise of GitOps and everything like that, we now have what we call infrastructure as code, which is where we can actually use tools that will boot the actual infrastructure for us. Vagrant is one of those applications. It's a free one. You can download it from HashiCorp's website. It works on both Linux and Windows as well. And basically what happens is you can then in code specify different virtual machines that you want to build, and you can then build them with what we call a provider or a provisioner. So what that means is you'll see that what I'm going to use today is VirtualBox, but there is a provider for VMware as well as providers for example, AWS. So some of the networks that we build, we actually directly interface with AWS to get them built, and Vagrant can do that for you as well. For those of you that are familiar with things like Docker, you'll know that you basically have a repo of various different Docker images that you can use, and you can essentially download a base Docker image and then modify that image to get it to do whatever you want it to do, and then save it again as a new image. And Vagrant is no different. There is essentially a bunch of different images that you can use on the Vagrant cloud. And essentially, if you look here, this is the most simplest example of a infrastructure as code example, where all we're doing is we're telling Vagrant to configure a new virtual machine for us and to pull the base image from the RGL group, which is a Windows Server 2019 machine. You can see that these machines are fairly old, so one note is that you probably want to update them when you use them. But the reason we like them quite a bit is that they can essentially be a base where you don't even have Windows Defender installed. So when you want to sort of like do a couple of trial runs with different EDR solutions or anything like that, you can actually install your own tools there. So I see that Vagrant is giving me a WinRM issue, which, I mean, it does that from time to time. So we'll just quickly get this one to reboot for us, and then we will get cracking into seeing what's actually happening there. Let's just force that. So with Vagrant and with Windows, one thing to note is that it does its provisioning through WinRM, which sometimes can be a little bit flaky. However, this is still significantly easier than doing all of the configuration manually. So when you work with Vagrant, essentially what you're going to have is you're going to create a directory for yourself. And in this directory, the most important file and the file that we will be working through while this network boots itself up is basically going to be the Vagrant file. So the Vagrant file is essentially where you specify your infrastructure as code. And then usually what we do is we create two separate directories. The one is a shared scripts directory. So these are scripts that we can essentially reuse for every single one of the networks that we are creating. So this helps us to reduce effort. And since we have these shared scripts on something like a Git repository where we can all work together, the nice thing is if someone makes an update here, we can all benefit from said update that comes out there. The other one that we then have is our provision directory, and this is where you keep all of the variables and the data that is specific to the network that you are currently creating. So let's say, for instance, that this specific network is going to host a web application. In your provision directory, you can create or you can store all of the web application files that you need right there. So that's just good practice to have that for your Vagrant setup, is to split those two directories. But let's start to actually look at that Vagrant file while the network is running in the background for us and busy provisioning. So basically what we have in your Vagrant file is we start with a simple line to just say that this is going to be Vagrant that's going to configure the network for us. And then we have a couple of variables that we define. So we have our fully qualified domain name, which is going to be smarter.lock with the rootnet BIOS of smarter. And then for our actual child domain, it's going to be hack.smarter.lock with an ADNet BIOS of hack. And then you can see here we have the host names of our various different machines and then also their corresponding IP addresses. So the nice thing about Vagrant, specifically with VirtualBox, is, and you can do this for other provisioners such as AWS as well, but the nice thing about it is by default it will allow you to create 2 network adapters. You can do even more. But essentially what that does is your first network adapter will still be your NAT network adapter that allows for internet access, but then it will automatically create things like your host-only network in VirtualBox that allows all of these different machines to communicate together, should, of course, they be in the same IP range. What's nice about this, what we've done in the past, is we have created things like a DMZ, where for specific computers, we'd actually give them 2 sets of IPs, and using firewall rules and simulating even a pfSense router, pfSense firewall, we could actually separate them, so to say that they were hosts that are available in a DMZ, and then any of those IP addresses that you hit there were the first IP addresses that you would see. And then, of course, if you moved onto that host, it had a second adapter which was connected to the corporate network as well. So you can do more than one sort of network interface if you want, or you can just skip this entirely and it will only create the NAT adapter for you, but then you're not really creating a network that's communicating with each other. So in your Vagrant file, what you do is you essentially define or create definitions for each of the virtual machines that you want to create. And if we have a quick look here, we will see that essentially in this network, we are going to do 4 different ones. So we'll start at the top where we have a root domain controller that is going to be provisioned. Then we have a domain controller, which is our child, and we have a server and a workstation. It is essentially the machines that we will be working with today. With that being said, it's fairly simple or human readable to read the configuration of a Vagrant file. Just one thing that's important to note is that with the Vagrant file, it is actually sensitive to indentation. So it's similar to Python, where the indentation of the file is what is basically telling it that it's still within one of the classes. So you can see here that we have config vmbox, that's 1 tab or 1 indent further in there. So the first thing that we do is we tell it which base image we want to pull. Like I mentioned, I like to use the RGL images, but there are a bunch of other images that you can use there, and you can have a look on the Vagrant website if you want to look for any of the other images or one that you fancy. The nice thing about these is if I wanted to, for example, make this a 2018 machine, we can just do that. If we want to go back to 2016, we can. We can even go as far as like a 20R2 box that we want to go for. So that's why I like the RGL image repo, because it has all of these different Windows Server machines. But you can essentially specify what's going to be your baseline image. One thing to note with all of these baseline images, usually they conform to the standards of Vagrant. And what that means is that you always have an initial admin user, which is called Vagrant. And that's the user that is basically used during the provision process. And of course, when you boot the machine the first time, you can also use that Vagrant user if you want to log in there. So that's basically the first line. Then we are going to specify what's going to be the host name for this virtual machine. And maybe just a note on those images. It's not just Windows images. There's a bunch of Linux images, and maybe at a later stage we can do a demo of a configuration of a Linux machine using a combination of Vagrant and Ansible roles, which is quite an interesting one. But for this one, we're going to focus on Windows first. So maybe that's a follow-up one there. So we define the host name, and then basically this is a very cool hack. You can see where we found said hack. But essentially what we do is we make this virtual machine insecure, because we unfortunately need to do plaintext WinRM and force basic authentication for Vagrant to be able to provision this. Of course, any of this configuration that you do at the start, you can just remove it again at the end as well to basically get it to work for you there. But basically, we're just enabling WinRM, and we're making sure that basic authentication with WinRM works, which is what the Vagrant provisioner is going to use to configure it. And this is where I mentioned we are currently using VirtualBox. You can see that our provider is VirtualBox, and basically what we are going to do is we are going to override the default config. So we are going to give this machine 2 CPUs and 2 gigs of RAM that we want to give it. It's not a lot more to do here, just basically we want the GUI to show, and that's basically going to boot this initial machine for us. Now we get to the fun part where, like I mentioned, we are going to define the network, and this will be your second adapter. Remember, when you are defining your networks in Vagrant, always remember that they are the second, the third, the fourth adapter. The first adapter is always going to be your NAT adapter, and that is the NAT. That NAT adapter is the one that Vagrant also uses for provisioning. So please don't disable that one while Vagrant is doing its thing. But now the fun starts. So after we have that base image online, how do we actually configure it to do the things that we want it to do? And what we do is we basically provision it. So what we'll go through is we'll see that for this root domain controller, we basically have 3 different provision scripts that are currently running. And I'm going to work through them, but we want to provision our base, which is a nice little script that's just going to set things like your language, your keyboard. It's also going to load in one of the trial licenses from Microsoft so that we at least license the box at the start. Then we're going to go to how the network is configured. And then lastly, because this is a root domain controller, we'll go through how the forest is actually installed. So let's actually start with what's happening in this command. So when we tell it to provision, we are telling it to execute under shared scripts this provision script. And for this provision script, we are going to give it a couple of arguments. And that's basically going to provision it for us. So this ps.ps1 script is actually where a lot of the secret source comes in. And this is basically it. It's a very, very simple script. But the gist of what the script is doing is your Vagrant directory. So if we just go one back here. So this entire directory that you have here, when you create a virtual machine, by default, this directory is mounted to the file system of the actual virtual machine that is being provisioned. So the nice thing about this is you automatically have a shared folder. And with a shared folder, you can now copy things back and forth between the VM. So what we want to do, and why we have this PS script here, is we essentially want to make sure that that mounted shared folder is in our path directory when we're executing the script. And the reason for that is we might be in C Vagrant, but we want a script from provision and from shared scripts to work together. And essentially that's what this provisioner script is doing. It is basically just making sure that we set our location to where Vagrant is going to mount that file share for us, and making sure that we just essentially resolve all of our paths for that script. So if we start in C Vagrant and we take in as an argument a script that we're going to execute, we can resolve the path for it, and then essentially we execute that one with having essentially that context of the shared directory that we are in. So a little script that basically just makes sure that we are aware of the directory we're working in and setting that to the shared directory where all of our Vagrant scripts is. So that's your provisioner script that's going to run. Let's actually look at some of the scripts that it will be executing. So if we go here, we will start with the provision base script, which should be under Windows. Yes, so let's look at the provision base script. So I don't know why my syntax highlighting is not playing nice today, but in any case. So for this script, you can see that we take in one parameter. All of these scripts are PowerShell scripts. Just a note on that. You can write bat scripts if you want as well. It's just PowerShell is slightly easier to use in my opinion. But basically what this script is doing is just taking in a single variable, which is your zone. So the default zone is just the UK zone because that's GMT. But of course, if you give it a variable, that one will be overwritten. with a different zone. So if you don't specify a zone, we just force the zone to be UK. However, as you can see, I specified EN-ZA, which means that I specified South Africa. So it will basically set that as my zone. And essentially that variable is going to be used when we set the keyboard layout. So for our people across the pond there, they have that small pound key on the UK keyboard, which none of the rest of the world, I think, has, which is why keyboard layout is actually an important thing. But essentially, we just pull that zone to set your keyboard layout. Also setting sort of like your culture, which does your date formatting, your number formatting, all that wonderful things for you. Not too important. Then what we do is we basically just set your welcome screen and your keyboard layout. So again, just making sure that everything is working for your specific zone. And then we set the time zone so that we just make sure that zone is actually working. Cool. So then what we are going to do is we are going to configure your license. So essentially just your trial license. Now what we do is you can again see sort of like the documentation where we pull this from, but these are essentially public domain trial licenses that can be used. Just make a note of this. These are not legitimate licenses in the sense that you can't just use this license when you're deploying to production. You do actually need to load in a different license. So for example, on AWS, what we do with TryHackMe is we load in a license at the last time. I know it's still on some of the machines will say that like your Windows needs to be activated, but the license for AWS is actually loaded in. And without that license, if the AWS machine does not have internet access, it would actually stop working after an hour. So you definitely need to make sure that you get your licensing in order. But these are essentially just licenses that we can load in for the 2012, 2016, and 2019 machine, so that we can at least do the specific templating that we want to do before loading in our actual license. And then you'll see that there's two notes here. So basically what we're doing is we're making sure that all local accounts on this machine never expire. And then very important, and this can be seen as a misconfiguration, but we actually make sure that the machine account does not rotate within 30 days. So for those of you who are not familiar with the machine accounts, every single Windows machine has its own account and unique password. By default, that password is a 128-byte password that gets randomly generated every 30 days. However, when you are creating challenge VMs, the worst thing under the sun is password rotation, because it essentially means that everything changes. So what we're doing here is we're just basically disabling password changes to make sure that the machine accounts remain static for the duration of our lab. And that's basically what we're going to do in the provision base. So we're setting keyboard layout, we're loading in an evaluation license, and then we're just making sure that the machine account is not going to rotate so that it remains the same. This is especially important when you're creating Active Directory networks, because your machine that is domain joined has a AD object. And that AD object has the same password as the actual machine account. And when those two go out of sync, the machine essentially falls out of sync of the domain, and you basically need to remove it from the domain and re-add it again, which again, when you're creating challenges, that's the worst thing that can potentially happen to one of your networks. So we've gone through our provision-based script, as we can see here. So this is basically the line that's going to set our keyboard, language, time zone, and our licenses. And then basically we just tell Vagrant, you know what, for safety reasons, can you do a quick reboot for me of the machine so that we can make sure that that configuration actually takes place. Now we get to one of my favorite parts, which is actually how we do network setup. And this is similar to some of the network setup that we do for TryHackMe. But this is really the thing that I like the most. And as you would have noticed, if you've done some of the networks, there's a lot of complaints about DNS, but I promise it's the DNS on your Kali or your attack box machine that's giving the issues. It's not actually the DNS configuration of the network.
It's always worked for me once I set it properly. Yeah.
I've had so many complaints, and I think only one of them were legitimate, where the domain controller actually just killed itself halfway through a session, and that was the one legitimate case where DNS goes down because the domain controller provides the DNS. But it's very important when you're doing sort of like Active Directory hacking and all of that. DNS is a pivotal point. I think, Tyler, I was watching your YouTube recap of lateral movement, and at one point, I think you were using a IP address for that THMIIS, and it gave you an error for the authentication. And I think it was
Yes.
because you loaded a Kerberos ticket. And remember, Kerberos tickets do not work with IPs, right? They work with host names.
And that's what it
So
said.
that's
That's basically
why,
what the error message told me. Yeah.
yes, that's why DNS configuration is so important, right? Because DNS provides the host names, which is basically sort of the foundation that you need for Kerberos authentication. NTIM authentication can still use IPs, so it's good. It's good to have basically both of them as well. So, with that being said, let's actually look at what we're doing with the script. So we're running our provisioner script. We'll go through this network setup script, and you can see we're essentially providing it with two parameters. So what this thing is going to do, as we'll work through it, it's basically going to copy this for us, and then it's going to copy a CSV file that has DNS entries for us. So let's actually quickly look through that script and see what we are doing there. So the default one will be the network setup.ps1 script. So we'll go here. If my screen will work with me today. There we go. Okay, cool. So as you can see, this is a very, very straightforward script. It has some default values, which is network setup normal and dns-entries.csv. And essentially, if we don't get a script, we just basically set the script to network setup. Let's just also change that. I want to make it normal there, like it should be. So that's basically the script that it will copy. And then what it does is, if this one, let's just fix that one as well. That was a last minute change that I made. So basically, if we see that we are still using the default script, basically what we're going to do is we're going to copy that script to the C directory. So if you've done any of my networks, you'll actually see that network script is still there on those machines. And basically what it does is it creates a scheduled task which executes on start, which is then going to execute that network script for us. So that's how we work with TryHackMe, where your subnets can be different. But essentially what's going to happen is, as soon as that network boots, it's going to reconfigure DNS, it's going to reconfigure its networking so that it works with whatever subnet it finds itself in. And that's quite important because, I mean, we specified these IPs here, but let's say you were hosting a challenge on something like TryHackMe or even one of the other providers as well. You're not guaranteed that that is going to be the IP that you're going to get. So you need to have a script that is aware that its IP can change and basically making or adapting to that specific change. So let's actually look at what's going to happen for our root domain controller. So for our root domain controller, it will be this root DC script that is going to execute. And now we see syntax highlighting is back all of a sudden. So basically what we do is we get our IP address from our adapter, and we then just basically split it into its 4 octets. So for those that don't know, your IP consists of 4 octets. So it's the 10.10.10.10, right? Each of those is a octet. So we split that out. Then what we do is we essentially import that CSV file, and we remove all of the current DNS records that we have. Since this is the root domain controller, we remove them for smarter.log. And then essentially what we do is we know what our first, second, and third octet is. So we know what our network is. It's 10.10.200, for example. And then essentially all we're really interested in is the 4th octet, which is the one that we want to remain static for all of our machines. And essentially we add a DNS record for that. So now we have a DNS record for each of those different machines. Then, very important, since this is the root domain controller, our child domain controller is going to be the one that does DNS for itself. So what we need to do is we need to enable child delegation. So basically we know that our child is going to sit at .101. That's the part that we want it to be static. So we basically just make sure that we set the DNS zone delegation for smarter.lock for any child lookups. In our case, that's going to be, oh, that's not going to be ZA. You see, that's still some old config. So in our case, that's actually going to be the child of hack if we wanted to specify it, because we are going to do hack.smarter.lock. And then essentially we point it to our name server, which is childdc.hack.smarter.lock. And that's basically how we set up child delegation. So that means if we have any DNS lookups for hack, it would basically just do a recursive lookup on our child domain controller there to basically find that specific entry. Then we still want internet access. So for that reason, we are going to configure a DNS forwarder. And essentially what we do is we remove whatever forwarder was configured. And at this case, we're just sort of doing a default Google DNS forwarder. So if it cannot find the DNS locally, it will essentially send it out via a DNS forwarder. And now that we're finally done, what we can do is we can configure the DNS of our actual system itself. So we remove the record for smarter.lock because of course the IP for that is going to change. It's corresponding to the domain controller. And we add the new record for smarter.lock with whatever our IP is. And then basically we use that to set that as our own DNS on our Ethernet adapter. So that's basically the configuration that we do to get domain DNS services up and running on the root domain controller. While we're here, let's quickly look at what, let's just say right quit. Okay, let's actually look at what that looks like on our domain controller. Just want to see, perfect. So on our domain controller, it's a little bit more simple. So this is the child domain controller. And what we're going to do is again, get our IP, again, get all of our records from the CSV, remove the old ones, add the new ones, and then basically just update our DNS server. So update the zone name for hack.smarter.lock, update that one. So by removing what the old one was and setting that to our new IP, because remember, we're the domain controller, so that zone should be pointing to our IP, and then setting our self as the DNS IP. So this one is a little bit simpler because we don't need to do things like delegation. It's a little bit more straightforward. And then the easiest one out there will be this one, which is the normal setup. And all this is doing on every single one of our machines is getting the IP and then making sure that it points its DNS to .101, which is where our domain controller sits. And that's basically it. That's how you make sure that whenever this network boots, as long as those fourth octets, so 100, 101, 150, and 200, as long as that remains static, right? Like you'll always have DNS no matter where this network is going to boot. So that's how we solve DNS issues 90% of the time. There is still the case where it can fail. And just maybe to quickly show what that little CSV file looks like, we'll go into our variables because again, this is unique for our case. And you can see it's fairly simple. It's hostname and IPN. So there's an example, .200. There's a server that's hosted there, and there's a workstation that's hosted on .200. And our hack.smarter.lock is at 101, and smarter.lock is at 100. That's basically what it is. It will pull its first 3 octets and then configure the fourth one for us.
That is fascinating. I know when I set up my lab, I use Windows Server Core, right? So it's all command line. And this would have saved me so much time because I did many of these commands, but this is really cool.
Yeah,
fascinating stuff.
That's actually an interesting thing to talk about, right? Because I mean, I'm not sharing all of the scripts that we have because a lot of them is actually intellectual property. But how we created the scripts is execute the code. Well, no, start with the Microsoft documentation, right? There's a bunch of get, add, set commands that are available in PowerShell. So you start with the Microsoft documentation. What do you want to do? I want to configure DNS, right? I want to essentially, if we look at this script here, I want to have the ability to add a new DNS record. So let's actually, for interest sake, let's actually do this. So we go Microsoft add DNS record. We just basically do that, and we say PowerShell. Let's just force it. Cool, here we go. Okay, there's the Microsoft documentation. So we go to the Microsoft documentation, we go to the examples, we see sweet. That's how we add a new DNS record, right? So you take that one, you execute it manually, you see that it works. And if it works manually, what you do is you add it to your script. And all of a sudden what you do is you specify parameters. And this is how we built all of these scripts from the ground up. It starts with the Microsoft documentation, goes into executing them manually. And once we know that they are actually working manually, it's that simple for us to basically just go and create a script of it and then import that script into Vagrant. And that's it. There you go. You have officially created infrastructure as code, which is an awesome thing. So now that we talked about networking, let's actually get to the interesting stuff, such as configuring our forest. Now, again, this is literally Microsoft documentation. So we go Microsoft PowerShell configure AD forest. And then what we're going to get is we're going to get the set AD forest and the install AD forest, as you can see, and the examples of how they work. That's basically it. And that we are now going to make a script. So if we have a look at how the script is going to work, I just want to show the variables as well. We can see that we tell it install forest and we give it a forest variables.json file. So let's just quickly look at that JSON file first. Variables forest variable. So basically what this JSON file is it contains a bunch of the variables about our domain. So we have the name of our domain, we have the fully qualified domain name, we have the net bias name, we essentially have the distinguished name, and then we have the administrator password and the safe mode administrator password and our DC IP address. So these are the variables that we are going to pull into our script, which is going to create the forest for us. And for those of you that don't know, so forest, so Active Directory, we call it a forest when there's a couple of different domains that work in it. And essentially the forest creates your trust boundary. So when we create smarter.lock, that is essentially our first domain, and za.smarter.lock or hack.smarter.lock will actually be part of that forest, right? Because it's a child of smarter.lock, and that's essentially where the trust comes in. But we would not trust smarter.com, right? Because that would be a different domain and essentially a different forest. We can configure trust between them, but essentially the forest is the trust boundary. So let's actually quickly look at that Active Directory script. Install forest.
I noticed you use Vim as well, so you're a true hacker. I still don't know if I know how to exit Vim. For one of the CTFs, I said you have to exit Vim, and I definitely had to Google how to exit Vim properly.
Well, at least there's Google to help you there. We we in the office have many fights between Vim and Nano. And it got so bad that some of the people actually replace other sort of like Nano binary. They overwrite it with Vim just to be correct. So like you're either going to learn this or you're in for a bad time, even if you run the Nano command.
That's hilarious.
So, okay, so basically what we're doing is this is a sweet little command where you can get all of the content from a JSON file. So you just basically say get content raw path and you give it that forest variables and you just pipe it to convert from JSON. And now you have all of those variables neatly available in a single variable. So the first thing that we need to do is we need to reset the administrator account password and settings. So basically what we are doing here is we are taking that new administrator password that we have, and we are then essentially setting the local user to administrator, making sure the account never expires, because for the safe mode administrator, you never want that password to expire. Otherwise you're going to break things. And then basically we are configuring setting the password, making sure it never expires. And that the user may change the password. We set that to true because remember, when you're performing a domain takeback, you can rotate the password, but for all other purposes, that password should remain static. So That's our new administrator password. Then we are essentially installing the Windows features, and this is quite a neat trick that you can do if you want to use infrastructure as code. So if you've ever gone onto a server and you've gone to add additional server roles and different things that the server can do, it's essentially just executing the install Windows feature PowerShell command. So you can just look up what the corresponding one for PowerShell is, and then you can execute it. So you can see we are installing the 80 domain services, the RSAT 80 admin center, and the RSAT additional tools that we are installing there. Then we configure our safe mode administrator password because we need that for our Forest installation. And we just execute the 80 Forest installation command. Install 80 Forest, create the DNS, create DNS delegation. We're not going to create that because remember, we create that ourselves, right? The Forest mode, the domain name, net BIOS name, safe mode administrator password, and no reboot on completion and force. And that's it. This is literally executing the command that you find in your Microsoft documentation. If you go to install ADDS Forest, you'll see this is exactly that command there. So don't start necessarily by having everything automated because you're probably going to waste time. The best thing that you can do is execute the command manually. Once you know that it works manually, put that in a PowerShell script, and there you go, you've now created infrastructure as code. So this is how we install the Forest, and essentially that is it for our first domain controller, which I see has configured itself by now. So we can just do that, and we can still lock in with Vagrant because that was our provisioner user and we haven't yet deleted it. But if we go here and we go to 80 users and groups, it's gonna play nice with me today.
So the real question is on TryHackMe, is the Vagrant user still Vagrant and I can just cheat by logging in as that user?
That would be so easy, right?
Yeah.
Why don't you give that a go and tell me whether I remembered my steps to remove it? No, I've removed it.
You did.
So the Vagrant user is still active because
I knew that part of it.
I do still actually use it for some other things, but no, I've changed the password, stored it in KeyPass. So yeah, good luck trying to use that method to break it.
Sure.
Okay, so as we can see here, we now have the smarter.lock domain that was configured for us, and we can see that our domain controller root DC is there. So this is it. We have officially configured our root or our parent domain in our Forest that we're configuring today. So that's it. That machine will just put that one aside. Let's continue with our domain controller. And the reason I'm running all of this in the background is it takes about an hour and a half for the entire network to verify. Ooh, we can see here, we are now currently, where are we at? So it is on this machine, our domain controller, and it looks like we are in the process of installing the domain. So we can see that we have reset the administrator account and we're currently installing the 80 services. So that's currently what we're doing. So we'll give that one some time to run. But as I mentioned, that takes an hour and a half on its own to get sorted. Cool. Let's continue to our domain controller. So again, everything the same here. We're pulling from the RGL 2019 images. We are configuring with VirtualBox, 2 CPUs and 2 gigs of RAM. Configuring our next private network. So that's going to be our host only on .101. Now, there's one additional command here called the Sysprep command. And you actually do need to install something for Vagrant to get that working. So Windows Sysprep Vagrant. Google is just such an amazing tool. So basically, you just need to make sure to install this plugin. So Vagrant plugin install Vagrant Windows Sysprep. Now this is actually needed. So why we sysprep these images is because we're pulling all of them from the RGL group and we're literally pulling the same image. Is one slight issue if we want to configure Active Directory, which is that every single one of these machines have the same SID, right? And the problem is Microsoft for Active Directory, right, joins on unique SIDs. So essentially what Sysprep is doing is it's just basically flushing out all of that, making sure to rotate the SID to something else, which means that when we call the command for joining this to the domain, it doesn't see it as, but wait, I already have this SID in my Active Directory structure. So never forget to sysprep your images apart from your root domain controller, because otherwise your joining is not going to work. Cool. Then we have our keyboard layout that we're doing. Again, those are sort of the basic stuff that we want to do there. And then we have where we create our child domain. So let's actually go see what this install domain script has installed for us. Okay, so I see syntax highlighting is gone again. So for this one, we are taking in the domain variables and the parent domain variables. So again, if we just quickly have a look at them, you will see that it's essentially the same thing. Where am I? Oh, I need to go to back. Provision variable. Add domain variable. So you'll see that it's, again, exactly the same type of thing, just this time for the child. So name hack, fully qualified hack.smarter.lock, hack. And you can see we now have a new administrator password and safe mode administrator password. That's just to distinguish between our two domains that we are going to have here. Okay, so we pull in those variables. We basically just convert them to JSON objects. And then what we start to do, and this is quite important, is before we can join a new domain, we do actually need to point our DNS to the parent DC. Because again, if that is not correct, then it's not going to be able to essentially install the domain. And you're going to see we do exactly the same when we want to join a computer to the network. So this is one case where we need those IP addresses to remain static. But again, this is just during the provisioner phase where we just make sure to set that as our DNS to point to the parent DC. Again, we reset the local administrator password. We install the AD tools. And then essentially what we need is, remember, we are going to join to the parent. So we first need to keep the parent's password and the parent, essentially create a parent credential, which is basically just a parent password converted to a secure string. And then the parent DA, which is essentially just going to be our parent name / administrator, that account that we set up. So we create a new credential pair. And then again, exactly the same command as what we executed last time. It's just that this time we specify some of the data about our parent, such as the parent domain name that needs to be specified. And essentially as well, it's somewhere in here where we specify the parent credential. It just, for the death of me, can't find it now. Am I going blind? Probably. There we go. Dash credential, parent credentials. So essentially we are specifying the parent credentials to make sure that we can create this new domain, which is now going to be our child domain. And if we look, is this positive? Restart needed. IP adapter. All of this looks pretty fine. Yeah, feature, installing, please be patient, warning. I don't care about warnings. Warning, warning. Okay, looks good. Looks like this one is essentially going to join to this one now.
Cool.
Okay. Cool. So that is how we install the domain. So there we go. Then we do the network setup, which again we have discussed already. And then, and this is by far my favorite script, because this is how I'm able to get 6,000 users in those TryHackMe networks, is essentially create 80 objects. So this is the script. This is where it's at. So essentially, you'll see that we pass it the domain variables, which is just so that we can get the script to authenticate to the domain controller. And then what we do is we pass it this planned users.json. So let's actually go look at planned users.json. And then we will take a look at the rest. So now, this is essentially how planned users.json looks, and we essentially have like Python scripts that generates like a bunch of random data for us. So it uses probabilities and everything, where we tell it like there needs to be 5% tier 2 administrators, 2% tier 1 administrators. There's a bunch of different things that it does, but you can also for a start just do this manually, which is the one that I can give to users. And then of course, if you want to create an automated process that randomizes this for you, that's something that you can do on your own. But essentially what we do is we just specify a bunch of different objects. And when I go to the PowerShell script, you'll see how we basically wrote that, but it's not that hard to just do additional AD objects if you really wanted to. But what we're going to do is we're going to start by creating some of our organizational units. So we'll create the organizational unit of admins under the base directory. And then under that admins organizational unit, we are going to create the tier 0 admins, the tier 1 admins, and the tier 2 admins. So for those of you that sort of don't know about domain tiering, it's basically a good security practice that they've released in the last couple of years, where essentially your biggest issue that you have is a misconfiguration or a exploit called credential shuffling. And I think that's sort of the thing that made Bloodhound as popular as it is. And don't get me wrong, it has a ton of other features now, but credential shuffling was really the attack to do over the last couple of years. And what that does is essentially, I get onto a machine where I'm administrator. I interface with LSAS using something like Mimikatz to dump credentials from that machine. One of those credential pairs is a more privileged credential pair, so I do a pass the hash attack using that, authenticate to another machine as administrator, dump the credentials, get a new privilege account, and basically repeat that process until I'm a domain admin. Sure. And the reason that's possible is because credentials of different privilege levels were logging in, doing interactive logons on devices where lower privilege or lower tiered credentials had administrative rights. So what Active Directories or Microsoft essentially said is, look, if you split our credentials, then that doesn't become a possibility. So tier 2 usually refers to your workstations, right? So any tier 2 admin is someone that has administrative access to a workstation. Tier 1 is anyone that has administrative access to a server, and tier 0 are accounts that have essentially administrative access over things like domain controllers, your SCCM servers, all of those wonderful things. So let's say you compromise a workstation and there are tier 2 administrators interactively logged in there. That's fine. If you dump their credentials, that should still only give you access to all of the workstations. It is not going to give you access to the next tier. You would need to find something else that allows you to get onto a server as an administrator to be able to dump tier 1 credentials. And even if you do that, it's still fine because it's not your tier 0 credentials which are compromised. So essentially, by splitting these credentials out into different tiers, what that does for you is it makes sure that when one of your tiers are compromised, it doesn't lead to the compromise of an additional tier. Now again, human error is a big thing, and if someone does an interactive logon with their wrong credentials because a domain administrator is just too lazy to make use of his tier 2 credentials, so he just specifies his tier 0 account, you have a problem, right? That's still an interactive logon that's going to happen, and then those credentials can essentially be compromised. But this is just for best practices. So back on track. We create organizational units for all of those. Then we create an organizational unit called groups, where we are just going to store all of the groups that we want to create. And then remember, these are just organizational units. We still actually need to create the groups because we want to configure a group policy object for these type of logins. So we create a tier 0 admins group, a tier 1 admins group, and a tier 2 admins group. We then create organizational units for our servers and for our workstations, which is nice because when we then create group policy objects, we can have specific policy objects applied to all servers and specific policies applied to all workstations, which just helps us. And then we create our organizational unit for employees, and we are going to add different departments here. So we add IT, sales, and marketing currently there. So that's how you can see essentially the type specifies group or organizational unit. The one other type, which is a nice type to use, is the user type. And essentially with the user type, this is how you create a new AD user. So we can see here that we're creating a tier 0 account, which is nice. We are then also basically just specifying the first, the last name, the OU path where it should create it. So this one we wanted to sit under that tier 0 admins one. Just a note with the organizational units, they should always be in reverse. So remember, admins is the top one, and then tier 0 admins is the one underneath it. So Active Directory has this weird thing where you need to specify the underneath one first, then the top one. So you basically work it back that way. Don't ask me why. And then basically you can see we are setting a decent password for our tier 0 account. Then we create our tier 1 account exactly the same, and we create our tier 2 account, and then we create our normal user account. And that's how we now have 480 users in here. Now with the manual process, it does still take a little bit of time to do 6,000 users. However, as I mentioned, we just have a PowerShell script that creates this JSON file for us with randomized users and randomized passwords, and essentially then we can use that. So let's actually look at what that script does. And this script is a prime example of just reading the Microsoft documentation. So you can see that currently we can create OUs, groups, and AD users, and then also group membership is something that we can do. So what do we do here? Basically, we just get our domain variables, which is going to allow us to authenticate to the domain. And then what we do is we are essentially, and just give me a second, I just want to make sure, yeah, this thing is still running. Hopefully it connects today. Okay, cool. So what we are then going to do is you can specify more than one file. So in our case, we have planned users, which is part of our attacks. And then we have what we call AD random. So you can specify more than one JSON file, and this script will essentially read all of them. And for each of these files, what it is going to do is it is basically going to iterate through every single one of these objects. And again, this is how we created the script. If the type is OU, we add a new OU. And this is literally us going and saying Microsoft AD add new OU PowerShell. And we find it and we see, cool, this is the command we need to execute to add a new organizational unit. Look at some of the examples, right? And then basically what we do is we essentially just do that. So we go get the organizational unit for that name. And if it does already exist, we just continue. Otherwise, essentially what we do is we just say new organizational unit -name object.name, and we add it to the path. That's it. If it is a group type that we want to add, again, Microsoft documentation, Microsoft, and we go AD add new group PowerShell. And here we go. There is the new AD group. We go here, read the documentation, see one of the examples and everything like that. And then once we're ready, we say, perfect, let's go create that. So if this AD group, we first test whether the AD group exists. If it doesn't, we essentially create it with new AD group -name, SAM account name, display name, path, and global for global scope. That's it. Otherwise, if it's a user object that we want to create, exactly the same process we're following here. We go read on the Microsoft documentation how we create it. First, check whether the user exists. If the user exists, do nothing. Otherwise, what we can essentially do is we get some of the optional parameters for the user, right? Because it's not always that we have a given name, a surname, or a display name. So basically, we're adding those as optional parameters for the user that we want to create. We configure the user's department, member, and then essentially sort of their SPNs that we are going to set. We take their password, convert that to a secure string, and then we run the command, new AD user, and essentially what is their name, their SAM account name, and all optional parameters we specify as well. And then what we do is you would have seen that there's that little bracket, that array in that JSON object that essentially allows us to specify groups. And what this does is it iterates through all of those groups and basically just runs the PowerShell command for add AD group member with that group to basically make this person a member of that group. And that's how you populate your entire Active Directory using a single script. Now, again, the current support is only for those for these AD objects, so OUs, groups, and AD users. But if you want to support any other types of objects, it's not that hard to just essentially go read the Microsoft documentation and modify this script so that you essentially make sure to run it for whatever you want to run it for. But this does make your life easier if you're creating challenges and you want to populate with a bunch of different data. So that distributor application that's available there, it's basically just pulling from one of those JSON files a set of credentials for you and toggling it that those credentials are in use, which is why every user can have their own set of credentials, which is nice because it just creates a little bit of segregation between the different users or students, which means that you technically can't find the files of one of the other students unless you're administrator. But that, in a nutshell, is how you populate a bunch of different AD objects into your AD. And let's see, this domain controller is taking ages to boot today. Hopefully, oh, you know what? I know what's wrong. This is a me problem. Cool. So let me actually show this. So the one issue that I've had, and again, there might be a different solution for it, but DNS, it's always DNS that screws up. But essentially what happens is because we have a NAT adapter as well, our primary domain controller is trying to contact, or our child domain controller is trying to contact our root domain controller, not on the 10.10 IP that we specified on the host-only network. It's essentially trying to do that now on the NAT adapter, which is not going to work because NAT doesn't allow communication between these two machines. So the quick trick that you can do is when you, and you only need to do this when you're joining child domains, is you basically just disable your first adapter, which is your NAT adapter, and then it should work. But I might have been too late, which means that this one is not going to find anything. So why don't we just do this? So you don't have to just run Vagrant up. You can boot these machines in whatever order you want. So we'll just re-provision this one. We might finish the domain controller and not actually the server and the workstation for today, which is fine. I mean, it's going to run in the background. Okay, cool. So let's hope we can get that one done. It should be 30 minutes. Okay, and now that one should work. Okay. Cool, so that's basically how we created our domain controller. Now there's a bunch of other things that you can do. So things like group policy objects, right? You could create a script for that, which will essentially apply group policy objects to your domain for you as well. And any types of scripts that you wanted to do here, you could create a script for it and run that to basically make your domain more populated. And the nice thing is once you create that script once, you can reuse it constantly. So let's go look at our server and workstation, which is going to be fairly quick because there's not a lot of new things. So essentially we run Sysprep, as we mentioned. We want to make sure that those SIDs are rotated. And then there is one additional thing that we're doing here, which is installing Cocoa. So for those of you that don't know, you get a thing called Chocolatey. So I'll quickly go to that. So let's go to Cocoa. So basically, we are installing Chocolatey. And what Chocolatey is it's like a package manager for Windows. Yeah, it's not, I don't think it's like licensed in a sense that it's like endorsed by Microsoft or anything like that. But it's like the most amazing thing ever because you can literally go Cocoa. Geez, I can't spell today. That's wrong. Chocolatey. Office 365. Cool. Yeah, this one. Packages matching Office 365. Cool. Let's try this one. So if I want to install Office 365 on my machine, I just run Cocoa install Office 365 Business. What about Chrome? Let's go for Chrome. If I want to install Chrome, which we are going to do on the workstation, I can just go here and I can just run Cocoa install Google Chrome. So I don't
never heard of that before.
Yes, I don't need to keep a bunch of different binaries or anything like that. I can just use Cocoa to install everything for me. So by default, on all of my servers and on all of my workstations, I essentially just install Cocoa, which means that I can install whatever else I need. Now, it's just important we install, in your Vagrant file, you install Cocoa before you actually join it to the domain. Because remember, once you join it to the domain, there's a bunch of things like DNS. And as you saw, I disabled the NAT adapter on the root domain controller. So my DNS doesn't currently have internet access at all. So it's just good practice to just install all of those things before actually joining it to the domain. Because anything, you can think of it this way. After joining the domain, scripts that don't need network access. Before joining the domain, scripts that need internet access. That's just generally a good rule of thumb to execute there. But you can see we install Cocoa. Currently, we're not installing anything else with Cocoa, but it's good to have it there so that we can install whatever we want at a later stage. Then we provision the base, same thing, and then let's quickly run through. So this is the only one that's different now, which is joining the domain. So let's actually see how a domain join looks like, and you will see it's exactly the same type of thing again. So what do? We pull in our domain variables. By default, it will be in the default OU, but as you can see, we are overwriting that by specifying that we want it in the server's OU, because this is going to be a server for us. And then basically what we do is we point the DNS to our domain controller. After doing that, we essentially create this new AD object for the machine account. So we create it. There we go. And then basically what we do is we just say add computer. So add computer to the domain name with the net BIOS and essentially the credential and any additional parameters, which is essentially this what we created, the OU where we wanted to add it. That's it. You've officially joined a computer to the domain, and you're not doing anything funny with Vagrant, right? You're doing all of the steps you would have done through the Microsoft documentation manually. You're just adding that to your script, because if you're going to do this 10 times, might as well just have a script do that. Whether you use Vagrant or not, right? Like having a script to join to the domain is an excellent script to have, because you're probably going to use it a couple of different times. So that's how we join to the domain. And as you can see, that is essentially the basics of it. And then we do the network setup, which was already explained. That's it. I see I have a double reboot, which is technically not needed, but there we go. That's basically it. That's how you configure a server. And from a workstation perspective, exactly the same stuff, just on workstations, we want to install Chrome. Now you will notice that my workstation, I'm pulling that from Windows Server still, and you would have noticed in the TryHackMe networks as well, the workstation or jump host was still a server. But the reason for that is Windows 10 licensing is quite expensive. No matter where you are. Server licensing is significantly cheaper. And you don't necessarily get that much more value making a workstation a Windows 10 machine versus making it a Windows Server machine. Especially for challenges, it's nice if you can install things like the RDS tools, which allows for multiple remote desktop connections. So I just make my workstations server images as well. But you could, of course, make these Windows 10 images if you had the bank for all of those licenses. That would be nice. But then the only other thing that we do is we can see we run the install Chrome one. And I do think I actually have a double chocolatey installed there. But if we quickly go here, install Chrome. No. You can see that's it. Cocoa install Google Chrome -yes. That's how you install it after doing chocolatey. And that's it. That's basically it. And you can see when we join it to the domain, we are now joining it to workstations instead of joining it to servers. And there you go. You officially have a AD network with 4 different machines with one single script. Now, as you can see with my provisioning and everything and having to restart it a couple of times, it's not perfect, but it's definitely significantly less effort on you as a person to create these type of networks. And now you have a base network with 4 different machines that can be 5, 6, 7, 8. You could create different child domains. You could create different computers under the different domains. But this is a good starting point in my opinion. This is a good base template to be able to build whatever network you want from this template.
And is there any other kind of gotchas? You know, you mentioned with the network adapter, is there anything else we should be looking out for when we run this?
So none that comes to mind now, but the most important thing is read your errors, right? So like your errors is definitely going to be the thing that's going to help you with things. I mean, what error did I have here? So like, for example, there's a timeout on the WinRM, right? Luck of the draw, during a live session, it's going to fail on WinRM, right? Let's just restart. Maybe it's because we're talking on Discord as well, so the network is a little bit congested or whatever.
Sure.
But luck of the draw. The biggest thing to do is to read the errors, and the other thing that I can highly recommend is get into the habit of actually executing this part yourself. To start off with. So what that looks like is it would look like to say cd to Vagrant, right? You would do that. And then what you would do in command prompt, you would say PowerShell -c and then shared scripts.ps1, and that should be a slash, right? So we say that. And then your arguments. So in our case, we can just go copy them out. So let's do this one. Like that. So I would execute that, right? And by executing that, we can see whether or not it works, whether there's a failure. Because as you can see, like the initial provisioning stage does take quite a bit of time. And you don't want to waste all your initial provisioning step, right, just for like one of your scripts where like that should have been user instead of users, right? And then it's destroyed and then it's re-provisioned. Because remember, this is not Ansible. With Ansible, you can re-provision. With Vagrant, like, no, just don't go there. It's way simpler to just basically restart again. So that's honestly the best advice that I can give, is execute those commands manually. Make sure that they work. And then once they work, you should be sorted.
And how can we get all these scripts?
Cool. So what I'll do is I'll create a zip file for them, and then currently I'll share them on the Discord.
Awesome.
I still need to see whether we can host them on a repo or something. For now, I'm going to share them on Discord, and then hopefully if there's someone on YouTube or Twitch that are interested in it, they can join the Discord there to go pull them. At a later stage, we might start like a repo so that a lot of us can contribute together to all of these different scripts. Like I mentioned, we have a bunch of other ones, but some of those scripts are unfortunately IP. My favorite one is from one of the scripts that I wrote, which boots up an entire Exchange server for you.
Fascinating.
That was hard. That was one of the hardest scripts I've written before. But essentially, after you have your domain, that literally makes all of the Active Directory changes that you need to install like a full-blown on-prem Exchange server, and literally creates a mailbox for every one of those 6,000 users.
Wow.
Yeah. That one was
is that a hint at what's to come on TryHackMe? Is there going to be a network with, we get a hack into Exchange type stuff?
So the one thing that we are looking at, which I think will be quite an interesting thing, is essentially sort of like, there's a lot of good training material on TryHackMe, but like we also need a way to almost like have an exam. You've done all of the training material, but like where do you actually test your metal, right? So one of the things that we're looking at is specifically for the raid team stuff is create a network where it's more in a exam format. So it's basically a CTF type of thing for a full-blown network. And I mean, there will be some interesting stuff, such as, for example, phishing in. And I'm hoping we can make that type of things quite realistic. So you have the opportunity of either using something like phishing to get in, or you can breach the perimeter, and then sort of following through on like Active Directory enumeration. And there will be some evasion techniques, right? It won't be my RGL images. I don't know if you saw, but I can do anything on these RGL images, and there's no AV. So like Mimikatz is on this machine, and Rubius, and like nothing gets flagged or gets deleted. And that's just basically because we explicitly, for teaching Active Directory here, like, let's not worry about AV evasion and everything like that at this point. But it would be nice to have like an exam network where you can actually test your skills and how much you truly learned. So hopefully those are some of the things that are still to come.
Gosh, that'd be cool. And does TryHackMe, and maybe you can't answer this or you don't know, does TryHackMe have any plans of having like legit certifications? You know, have some type of TryHackMe cert with that kind of that hands-on certification type stuff, or is that not in the plans?
I don't know whether it is in the plans. I can't answer that. I know that there's been discussions around it, because they do have those certificates for completing a learning pathway, which I see as being quite cool, as like a way of proving you've done something. But again, if there's going to be exam networks, there has to be a certificate attached to that, right? It can't just be a badge, but like here's my certificate for completing a learning pathway, and here's my certificate that proves that in a completely unknown environment, I was able to do exactly the same thing. So I think there will be something like that in the pipeline, but there's a lot of things that they are currently focusing on. And I don't know sort of like what the priority of something like that would be, or when that would actually be introduced.
Very cool, man. I'm excited to dig into this myself and see if I can figure it out. So for those of you watching, especially after the fact, in all my YouTube videos in the description, I have an invite link to our Discord. And so this is going to be limited to Discord. If you want access to these files, you have to join the Work Smarter Discord. So you'll notice there's a little logo, Hack Smarter. The Discord's Work Smarter. We just thought having a Twitch dedicated to learning cybersecurity and hacking and calling it Work Smarter was weird. So we made it Hack Smarter because we're not very creative. So we just changed one word on it. But join the Discord and we'll make sure the files are there. I'm excited to boot this up on my own machine. And so one other question that I know people might ask is, this is obviously built around VirtualBox, which is what I use personally. Is there any way you could make this work for like Vmware? Would you have to edit some stuff in the script? What does that look like?
So there will probably be a couple of edits in the script, but Vagrant Provisioner Vmware, geez, I can't spell this early in the morning. But at least Google knows what I mean.
Google knows all things, for good or for bad.
So you can see that like VMware is one of the supported provisioners. So you can go to GitHub for VMware Desktop, and then essentially once this opens, you will see that you can essentially install this plugin. So basically, this will now allow you to basically build using Vagrant and VMware. The one that we are exploring with this year, which I'm super excited about. My new lab at my daytime job is actually done using this one, is a AWS provider.
Fascinating.
So basically, Vagrant plugin install Vagrant AWS, and you can see for our provider, you then specify your tokens for AWS, and it then boots the machines directly into AWS for you. And then with a different override script, we are able to still do the default Vagrant provisioning and everything like that. But yes, there are multiple providers out there. I support VirtualBox. If you want to use something else, use it at your own peril. I can't give you a 100% guarantee that all of the scripts are going to work out of the box, because these were specifically configured with VirtualBox in mind. But I don't think it will be a complete rewrite to get it to work in something like VMware.
Sure. Okay. Very cool. I'm sure I'll have more questions as I go through this on my own, but man, are you sick of talking yet? You've gone like an hour and 20 minutes of straight talking. Have you gotten a drink of water? I don't think you took a drink of water.
No, I just woke up. So I'm used to presenting training, and that's talking for an entire day. And no, I don't like the sound of my own voice that much. So yeah, with the training, we at least take breaks and everything like that. But I thought let's hammer it out. Unfortunately, it seems like I won't be able to demo this network because I started it 30 minutes ahead of time. But as usual, when it's a live demo, you're gonna have some issues. So we can see it's getting ready to join the domain. But yeah, once this is booted up, you'll have that network, and like I mentioned, I'll create the zip and share that on the Discord channel, and then hopefully other users can have some fun with it. Just maybe one note on that: it creates this little thing called .vagrant. It's worthwhile to just delete this. Oh, I see this one is not big now. But basically, a lot of your images can sometimes be stored in things like this .vagrant. I think I reconfigured mine to actually store them in a specific, which is why mine is not that big. But just make sure when you share these type of things, before you share them, you just remove those hidden folders, because otherwise you might be shipping an entire Vagrant image with your Git repo. So part of your Git ignore, I don't know if I actually specified it in this one. This one has a bunch of stuff. Yeah, this one has a bunch of stuff. But basically, just make sure to exclude your .vagrant if you do something like a commit to Git as well, because otherwise, again, you might be uploading entire Vagrant images, which is not fun. I see we're close to joining to the domain again. Hopefully this time it will work. But yeah, I think that's it from our side. I don't know if there's any other questions.
No, I don't think so. I think we should be good, and I'll give this a shot as soon as I get the files. Well, maybe I'll probably go to bed now since it's like midnight here, early morning for you. But yeah, I'll experiment with this, get it booted up, and see what I can learn. And for those of you watching, if you don't have a TryHackMe account, make one. A lot of the new networks, they're really neat. The only one I have not done is exploiting AD, and tonight is my last night of streaming. Nate will be on tomorrow, Saturday, Sunday, and I think Monday. I'll be back on Tuesday, and on Tuesday we'll be diving into the exploiting AD network, which was created by am03bam4n, and I'm sure the base stuff was very similar to what we are seeing here. So you'll be able to actually do this and see. The only thing he hasn't shown us, which I don't think he's allowed to, is to show, specifically how to make these networks vulnerable to these different attacks. But it'd be a good research thing to look into those vulnerabilities and see if you can make your own network, make your own machines, make your domain controller vulnerable to something, then exploit that vulnerability. Would be a fun, almost like reverse lab, right? You make the vulnerability, and I'm guessing you have to understand the vulnerability better to make it rather than just to exploit it. So yeah, I'm looking forward to all that kind of stuff. I have all these possibilities in my mind of learning.
Definitely, and that's the best way to learn Active Directory and its misconfigurations. Even if you're a penetration tester, I think a lot of the times we take for granted how vulnerabilities actually came to be, and having something like your own network where you can actually replicate those vulnerabilities, you start to see how easy it is. The one example I have of that is the Active Directory certificate templates. I know you did the CVE room, but the other one where it shows you those 8 potential escalation vectors that the Spectre Ops team found. With the one, when I created that room, it's literally you click a checkbox and it pops up one yellow warning just telling you, yo, you sure you want to do this? And if you click yes, you've literally just created a privilege escalation vector that can allow any domain user to become an enterprise admin in one hop. And it's one yellow box, like one yellow box that is telling you, this is probably not a good idea, but you do you. Like, if you think this is what you want to do, give it a shot. And it's stuff like that that makes you realize how easy these type of misconfigurations can happen. So it's really, really good to recreate them yourself. And having a network like this in your back pocket is the ideal way to explore. Go create a Active Directory user. Go reconfigure the permissions for that user to be incorrect. Go do it. Have some fun with it and play around with it. And that's going to be the best way to learn. Just on that note, the one thing that I didn't show because my domain controller is not yet configured, but for your domain tiering, we have now created those tier groups, or we are in the process of creating them. You just need to also create a group policy object that actually enforces them. So what that would look like, and I mean, we can perhaps show it on this one so that users just quickly have that available. Yep. So if we go to group policy management, now, of course, we want to actually look at our child, which is not yet fully configured. But if we go here in your child, you would essentially have a server and a workstation group. So with that being said, let's take domain controllers as an example. You would essentially say create a GPO in this domain and link it here. And let's call this tier 0 logons, right? So something like that. We create that. And then what we are going to do is we're going to modify it. So we say edit. We go under policies, Windows settings, security settings, restricted groups, right? And we say we want to add a group. And then basically what we do is we say, in our case, that will be tier 0 admins, but remember that doesn't currently exist. Sure. So now I'm going to do something horrific by just specifying domain users should exist, yes. And then basically what we do is we create that. That should definitely be your tier, not domains users, unless you want it vulnerable, your own choice.
Very vulnerable, yeah.
Basically what you do is you just specify administrators, that I actually have to spell correctly. Cool. So we just specify that one and then you say apply and that's it. So now what's going to happen is this group policy object is for that group going to add them to the local group of administrators. So if you did this on your server OU, that would now allow your tier 1 admin group to essentially be part of the local administrators group on every single server instance, and the same with workstations, which now means if you use that T1 account, you could essentially authenticate to any of the servers as administrator and the T2 account for any of the workstations. And then for the domain controller, so for the tier 0 account, the easier way is just to basically take that tier 0 admins group and make it a member of your domain admins group. That's the simplest way, and that's how most organizations do it in any case. And that will be your configuration for it. Sorry, I can't show that because, of course, during the live demo, the domain controller fails to boot twice.
Oh man, it is all good. Awesome. Any closing words of wisdom, advice you would offer us?
No, just have fun. Don't be afraid to fail fast. It's the best way to learn. So red lines are growth when you see them on terminal. Trust me, I've done this for a couple of years. And red lines are the time to learn, to meditate. So just have fun with it. And if you fail, just pick yourself up and go at it again.
Man, that's good life advice. Red lines are a time to meditate. That is awesome. Well, cool. Thank you again for sharing, taking the time to share with us all of this just really good material. For those of you watching this on Twitch right now, after the fact on Twitch or YouTube, thank you also for watching. And go ahead and join our Discord, and would love to connect with you there, and we can continue to learn this and work through this together. So I'm going to sign off with those of you guys on the stream. Thank you again for joining, and Nate will be back tomorrow night. He's working through some Vuln Hub boxes, preparing for the OSCP, and I will be back on Tuesday, and we will dive into the Exploiting AD room then. So I will catch you guys